Good evening, friends. I'm here today to teach you Unit 2, Lesson 9, Graphing with Decimal Numbers. So the first thing, I know that you did rounding with decimals in your last lesson. So we're going to kind of go back to that a little bit today. And the first thing I want to do is you see these two numbers here, 726, and 8 and 729 thousandths. So the first thing I want to do is kind of revisit some of that rounding that you did yesterday. So if I were to round 726 to the nearest 10, what would that be? I hear you saying it, 730. Because we know this 6 tells the 2, you need to add one more. Now what if I was rounding 726 to the nearest 100? I'm going to round that to 700 because if I'm rounding to this place, I'm going to look at that number. 0 to 4, that line's going to stay the same. 5 to 9, add 1, that's the game. So the same rules apply when you're talking about decimals. So our 8 and 729 thousandths, I'd like to round it 3 different ways. The first way is to round it to the nearest hundredth. So that's this place. So if I'm rounding it to the nearest hundredth, I'm going to use the thousandth place to tell me what to do to that place. So 8's going to stay the same, 7's going to stay the same. So what's going to happen to my 20 hundredths? Well, I'm going to round it to 30. So the nearest hundredth would be 3. And honestly, I don't even need that 0 there. It doesn't change it at all. So now the next one that I want to do is I want to round this number to the nearest tenth. So I'm looking at 7. I'm going to look at 2. I'm going to keep my 8. And it's just going to stay 7. Because 0 to 4, the place is going to stay the same that you're trying to round it to. Now, nearest whole number. So if I'm looking at the nearest whole number, I'm now looking at the 8. And I'm just going to look at the next place next to it to tell me what to do to that 8. Just like I would anytime else. The decimal point's there, yes, but we're going to look at it and approach it with our rounding just like we would do any other whole number. So that 7 tells me that I need to add 1. That's the game. So taking all of this, how can we apply this to our real world applications? Today, I'm going to talk to you about how to use a graph and when that would be appropriate, and using rounding sometimes to read a graph. So the first one is this graph on common beetles. And some of the elements that I want you to notice in the graph are there's a title. A lot of things are labeled so that when we're reading it, we can read it better. So here you have the title at the top, so we know what we're looking at, length of common beetles. Down here, we have a title or a label so that we know this bottom section here is all the different kinds of beetles. So there's the bark beetle, the firefly, the ladybug, the seed, can't read it, seed something, and the seed beetle and the tumblebug. The last little title or label that you're going to see is the length in centimeters. So when we're looking, what is the length of a bark beetle? I'm going to go, here's the bark beetle right here. I'm going to see what line it's on. Okay, well it's between 0.2 and 0.4. So what would that measurement be, that line, be between 2/10 and 4/10. It would be 3/10. How much longer is a firefly, which is 1 3/10, than a bark beetle? Bark beetle is 3/10, so it would be 1 centimeter longer. I just subtracted what the bark beetle was from the firefly. Now here we go with an estimation. It says estimate the length of a tumblebug in hundredths of a centimeter. So here's a tumblebug, and it's just, we got 9/10. It wants hundredths. So it's not quite 1 centimeter because it's not to this line yet. So halfway between 9/10 and 1 whole would be 95 hundredths of a centimeter. Hopefully you see how I kind of split this entire section in half to get that 95 hundredths. The actual length of one beetle shown is 150 thousandths centimeters. Which beetle is that? Well, if you look at the thousandths down here at the bottom, we see that the seed beetle is just past the, it's the same kind of a thing as that last one, where we're looking between this measurement of 2/10, this measurement of 1/10, and it's kind of in between. So we're looking at the seed beetle. A June bug is about 2 5/10 centimeters in length. About how many times as tall as the tumblebug bar would the June bug bar be? So it says the hint is round the lengths to whole numbers to help you estimate the height of the June bug's bar. So I'm looking at the tumblebug height, and we've already talked about it here. We estimated the height here in number 3 to be 95 hundredths. So I'm going to round that up to 1 centimeter for this purpose. And then I'm going to look here at the height of the June bug, which is 2 5/10. I'm going to round that up to the nearest whole centimeter, which would be 3. So if I'm looking at approximately 1 centimeter for the tumblebug, and the question is how many times as tall does this bar need to be to represent the June bug? 1 times what equals 3? Well, it would be about 3 times as tall. Excuse the poor writing. 3 times as tall. And that's where estimating and rounding those decimals to whole numbers really helps you out. So that takes us into our friend Puzzle Penguin. And we need to kind of look at the mistake you made. It says, Dear math students, for the science fair I recorded the heights of several plants. A month after I put different fertilizers on them, I made a bar graph of the data. Did I make my graph correctly? If not, how can I fix it? Well, looking at these, looking at his bar graph, I see that says plant heights after 1 month. And I see that it says his height is in centimeters. So he goes 1 centimeter, then he goes to 1 centimeter and 3/10 of a centimeter, then 1 4/10, 1 5/10, 1 6/10, 1 7/10, 1 8/10. And the error that I'm seeing right away is there's something wrong right here. I want you to take a look at that, and in the form, I want you to see if you can give me an answer. So look for the puzzled penguin question on the form, but pay attention to the intervals here, and we're going to talk a little bit more about intervals in the next segment. I started filling in this table here just to kind of for the sake of time, but a chemist kept track of the masses of the different samples he tested. The box on the left shows this information. This box here on the right, we are rounding the mass measurements to the nearest hundredth to help us with graphing them. And I already did the first 4, but I wanted to start with sample E, and I'm looking at the hundredth, the numbers that I'm putting the little dot under. Then I'm moving to the right and looking to the next number. So 179 thousandths is going to round to 18 hundredths, because that 9 tells me I need to add 1 to the 7. In sample F, 162 thousandths is going to round to 16 hundredths. 110 thousandths is going to round to 11 hundredths. And what we need to do with this now is we need to graph it. And that's like the big part of this is the graphing. Numbers 8, 9, and 10 I will put on the form for you to analyze and answer. But what the big part here is, how do we graph these? So for sample A, they've already, look, title, label, these are the samples, this is the measurement. They've already set the intervals for you, so you don't have to do any of that thinking. So you just take this and you go to the top line, and you're going to draw a bar graph. They would call this a bar graph to show these masses, rounded to the nearest hundredth. So 17 would go up to the 17 line. This is one of those times where if you're drawing this in your book, you want to make sure that it's nice and neat in your notes, just so you have a good example. 13, oh, I kind of went a little past there, sorry. But hopefully you get the idea. 12, and this is what your bar graph would be. So if you were to write these samples in from least to greatest, what would that look like? Well, you could use the picture, or you can just use your numbers. But if I were to write these from least to greatest, they'd be sample, and I'm just going to put the letters here, G, and then D, and then C. I'm going 11, 12, 13. A is 14 hundredths. There's no 15. I'm going to go to F is 16 hundredths. B is 17 hundredths. And E is 18 hundredths. So, I mean, the key information here is that a bar graph can easily be made with any kind of data, but no, the big things are the labels of the data that's being shown, and the title of your graph, but also the intervals need to be consistent. That needs to be the same measurement. So if we're talking here, it's 100th. It's 100th difference between here and here. It can't be like 100th here, 300ths there, 400ths there. It's 100th between each space, or 1/10 or 2/10, whatever it's going to be. It needs to be consistent and the same all the way up your bar graph. We'll play a little bit more with this tomorrow, but check out your form, and you may be using some of the data in this video to answer those, and have a nice afternoon.